Welcome to Transformative Substation Design. My name is Slavika Bozek, and I will be your presenter today. As substation design professionals, we're constantly faced with a challenge to improve substation design, to improve the collaboration between design teams, to increase the visibility into project progress, and overall to improve the quality of our project deliverables, and of course, to reduce the cost of design. In this session, you will learn how Open Utilities Substation reduces errors, eliminates rework, and overall improves the quality of your design, while at the same time reducing the design time compared to traditional CAD-centric drafting methods. Those workflow design improvements are accomplished by integrating primary and secondary design of substations into a single discipline, providing an intuitive 3D modeling tools, automating most common and time-consuming protection and control tasks, and automating the creation of various reports and schedules. Before we start exploring benefits of Open Utilities Substation in more details, let's start by reviewing the key challenges with CAD-centric substation design. CAD-centric workflow usually has multiple entry points for the same information, and that ultimately leads to questionable and inconsistent information. Drafting tasks are very repetitive in nature, consume a lot of time, and they're very much error-prone. If the change is required to be made across the entire project, it is very difficult and the quality of an outcome depends on designer's level of expertise. Drawings produced in a typical CAD environment are usually inconsistent, they're lacking the standards, and they usually reflect the different skill levels of various project participants. Once design is complete, creating bill of materials, cable lists, cable schedules, wire schedules, and so on. Updating the same after changes are made can be a very time-consuming and error-prone process. Transitioning from 2D-centric CAD environment to a 3D-focused 3D CAD design is a very time-consuming and complex process that requires re-education and retraining of your entire workforce. Substation design revolves around work order, so managing the changes between multiple work orders or merging changes between multiple work orders can be a very challenging process where extensive collaboration between users is required to achieve the satisfactory outcome. All those challenges with CAD-centric substation design are substantial, so there must be a better way how to design your substations and move from CAD-centric design to ultimate destination, a digital twin of substation. And of course, the answer is Open Utilities Substation. In this presentation, I will explain in details how Open Utilities Substation solves each CAD-centric workflow problem. The first problem was the multiple entry points for the same information. So imagine if you have multiple single lines, schematic files, wiring diagrams, and so on, that all include the same electrical equipment. So if you make a change in single line diagram, you would have to make sure that you make the same change in all other files as well. Open Utility Substation utilizes the central project database. And if a change is made in a single file, the change is automatically propagated through all files that include the same piece of equipment, regardless if that piece of equipment is represented in a single line file, schematic file, and 3D file using different representations. It's still the single piece of equipment as far as database entry is concerned. And we're using the equipment ID or the symbol ID as the piece that connects the information across multiple files. So let's take a look at the example. In this example, circuit breaker has symbol ID CB2. And by changing symbol ID from CB2 to CB2-A, we're automatically making changes to all files that include the same symbol. So we can navigate from single line to a schematic mode, and the dialog showed us that there are 5 different files that contain circuit breaker, and we can see the symbol ID the circuit breaker ID is automatically updated. So moving to a 3D model, the circuit breaker is automatically selected because we navigated from the circuit breaker in a schematic mode to a 3D mode. And the next example, we're placing cables between circuit breaker and isolators. For cable placement, we're utilizing the hook points on isolators. So those hook points allow users to place cables without really having to zoom in and make sure that we select the right point. The right point is automatically selected because the hook points would accept the cables only, or would accept only cables that should be placed to that specific hook point. We can go back from the 3D model to a single line diagram. If you were doing the same in the CAD-centric environment, you would have to make sure that you first identify all instances or files where the circuit breaker is located and manually make the changes in each separate DGN or DWG file. With Open Utility Substation, you make change once, and when a user opens the file, the next file, the change will automatically take place in the background. One of the most significant challenges of CAD-centric design is repetitive drafting. Substation design consists of a lot of schematic and single-line drawings, which require a lot of repetitive drafting tasks to take place. So through design automation, Open Utility Substation can minimize those drafting tasks while at the same time improving design quality. So first, let's take a look at the wire placement. So there are various tools to draw wires. The obviously the most fundamental one is placing the single wire, and the wires are automatically taking the orthogonal path and automatically snapping on the connections between different pieces of equipment. And electrical components can slide across electrical wires, of course. If the component is deleted from the circuit, the wires will automatically heal and be ready to accept the placement of the next electrical component. So we can also copy electrical components from one circuit to another. So notice that the equipment ID is automatically changed. So according to rules defined for equipment IDs on this particular file, the next available equipment ID is automatically taken and assigned to the piece of equipment that was copied. In this example, the fuses that are copied from one circuit to another. The next very important tool is automated device ID check. So if user attempts to reuse the device ID that already exists in this example, we're using the device ID that exists in the same file. The engineering design consideration tool will prompt us of this and will not allow us to place the same ID. Instead, the next available device ID is used instead according to rules defined for device IDs on this particular file. The same rules can be applied for wire labeling. So if user attempts to label a wire with wire ID that already exists, the same engineering design consideration tool will notify user of this problem and automatically assign the next available wire ID instead of one that was already taken. For more advanced automation, Open Utility Substation offers Project Builder tool. With this tool, user can define the topology of the circuit in simple Excel file by defining the symbol IDs, the types of the symbols, and the tools to be used to place the components. And simply by selecting this Excel spreadsheet, and again, this is a template that can be reused for various projects, the entire project will be created in the background. So you can see that literally within the seconds, we have created a new drawing for substation design. And of course, this is an intelligent drawing, so users can modify or review any attributes assigned to any of the symbols in this drawing. Another major challenge in CAD-centric substation design is making changes across the entire project. So often, a single piece of electrical equipment lives in single-line schematics, wiring diagrams, 3D drawings, and making change across all those drawings at once is not possible in CAD-centric design. In Open Utility Substation, we have tools that will allow us to globally make changes from a single point and propagate through entire design. So first, we're going to review the data manager. First, provide users with a tabular view of the entire project and enable us to make changes without ever opening a DGN file. So users can change various types of components, editing wires, editing device IDs, cables, part numbers, symbols, and so on. And we can even limit selection to a specific equipment IDs or device tags, as we call them. So you can see that this particular device ID, CBA, lives in many different files, and we're going to replace CBA with CB1 using the replace all function. So we can see that this device is found in 50 different instances, and we have automatically modified all those instances at once. So obviously, we can see the change in this DGN file, but we can also see changes in all other files that contain the same device ID. So if we navigate from one device to another using our navigating options, we can see that IDs are automatically updated as soon as file is open. So user still needs to open the file for the change to actually take the place until the file is open. It's just a pending change in the database. So now we're looking at additional instance of the same circuit breaker. And we can see that device IDs change from CBA to CB1. So following the same principles, users can edit cables using the graphical user interface. So in this example, this specific cable doesn't have any text attributes associated. So adding text attributes to each individual cable would be time consuming. So instead of making changes one at a time, we're going to use the cable manager to make changes to multiple cables at once. So of course, users can edit individual cables. So in this example, I'm changing the part number for a single cable only, or we can select a group of cables and edit part number or any other attributes for all those cables at once. So again, the cable manager gives us the tree view of all cables in the project on the left side, and users can also swap targets, source and target, and we can add voltage level to cable, define the preliminary length of the cable, or add any additional user-definable attributes required for the project. So in this example, we have added two attributes, length and voltage level, to all cables in the project. And now when we go back to the same cable that we reviewed at the beginning and look at the cable text, the length and the voltage level that we defined through Cable Manager are now part of the cable text as well. In CAD-centric substation design workflow, checking the quality of your drawings is limited to ensuring that CAD standards are applied. It pretty much means if the correct line style, line weights are used for wires, if the correct levels are being used, if the correct cell names and so on are being used. Of course, all of that can also be done in Open Utility Substation, but there's a whole new set of tools in Open Utility Substation that will ensure that your drawings are not only correct from the CAD standpoint, but from the engineering design standpoint as well. So now we're going to take a look at engineering design consideration tool in Open Utility Substation. And we can check only selected files. If I'm a user, I would probably just limit checking only my own files. Or as an admin, you can check the entire project. So I'm selecting only to check for duplicate wire numbers and short circuits, and it didn't find any violations. So, which means I was using Open Utility Substation correctly. And now I'm going to expand this by checking for symbols without wiring connections. So you see there's a lot of symbols that are missing wiring connections, and we can navigate directly to a drawing that has this violation and correct this violation. In the next, I'm going to expand this even further and look for wires without wiring number and for conflicting destination, source, and destination IDs. And at the end, I have 3 different categories where the violations are found, and I can review each one separately. And again, just double clicking in error checking window will automatically open the file where the violation is found. In this example, we're looking for a missing wire size, and we open the wiring manager. Well, obviously the wire size is missing, so this needs to be corrected. Transition between 2D-centric CAD design of substations and intelligent 3D design can be very challenging simply because of the skill level the designers require in order to work in a 3D model. With Open Utility Substation, we're removing that barrier by introducing the concept of hook points. In this example, we have digital terrain model referenced in the purple reference file that you're seeing, and we're going to place the foundation for a transformer on top of this digital terrain model. So I happen to know the first few letters for the part number for this foundation, and by selecting the DTM placement method, notice that the foundation is simply gliding across digital terrain model and allows me to place the foundation effortlessly on top of the digital terrain model. So of course this works if you have slopes and so on. That's the whole purpose of digital terrain model. So we don't have to worry about the elevation. Simply by selecting digital terrain model, we're getting the correct elevation. In next example, I'm placing a transformer, and the only choice that users need to make when placing the 3D components, in addition to choosing the correct 3D component, of course, in this example, I'm looking for a circuit breaker, and selecting the correct component is the orientation or the rotation of the component. So there are several options how I can rotate this circuit breaker, and once I find the right option, the circuit breaker snaps right in onto the top of foundation because of the correct hook points between the components and the foundations for those components. And next example, I'm placing the connector. So obviously the connector can have logically only 2 possible options here. So simply by rotating connector left and right, I can go through these options and select the correct option for the connector. Placing cables, it's even easier. So placing cables simply requires selecting a connector, so I don't even have to select the proper point and connector. Selecting the connector itself is enough. The correct insertion point for the cable is defined by the hook points. And notice how my cursor is snapping only on the connectors because those are only possible placement points for the cable. So the only options the user have to select is the placement options for the cable itself, and the sag for the cable, and cable will be automatically placed. In the next example, we're looking at the smart copy and the smart move option. So by selecting the hook object and by locking the height, I'm moving not only circuit breaker, but all other components that are associated with the circuit breaker. Well, lighting protection is an integral part of substation design, and if you're working in a CAD-centric environment, you have to use a third-party application to perform lighting protection design. And it becomes really challenging if you don't have a substation 3D model, but if you're doing that from the 2D model. With Open Utilities Substation, lighting protection design is integrated into Open Utilities Substation, and we're utilizing a rolling sphere method where users are selecting desired level of protection, and as a result, the 3D rolling sphere is generated on top of the model, and users can review areas that are protected or unprotected, and there's also various reports that will help users to spot any areas of a substation that may not be properly protected. In this example, we're using a hybrid model of substation. So the lighting rods that I'm selecting right now are from the reality model that we have referenced in. And the overhead cable is placed in Open Utilities Substation. So it's very common that we have the existing substation and we're making a small change to the substation and have to verify that lighting protection is still satisfactory. So by selecting the correct radius or the level of protection, by selecting either just the lighting masts or a combination of overhead and lighting masts or overhead cables only, the rolling sphere is generated based on those parameters, and then users can review if there are areas of substation that are not properly protected. And there are also some reports that will help us to spot areas that are not properly protected. Creating a bill of materials and other industry standard reports in a CAD-centric substation environment can be very time-consuming and error-prone process. With Open Utilities Substation, we fully automate this process and eliminate the errors simply because the data is accessible from a centralized project database, which automatically ensures the data is consistent and accurate for all our reports. So we can place reports in DGN files, export to a variety of industry standard formats, and also users can create new reports or customize already existing reports in Open Utilities Substation, and we can also export to a smart PDF file as well. So this is the list of standard reports that are delivered with the Open Utilities Substation. So we're going to take a look at the just the standard bill of materials report. And there's a preview functionality that allows users just to get a look and feel for the report without actually putting that on the drawing. Or we can export this to a specific location locally or project-wise, of course, and select from a variety of industry standard formats for the reports. So this is, again, just a standard PDF report for the bill of materials. In addition to exporting to a variety of industry formats, we can automatically place the report on the drawing, and what it does in the background is it automatically creates the new DGN file and places the report on a DGN file. So it actually combines quite a few steps into a single step for a user. The next report we're looking at is the field wiring report. This is a very commonly used in the field. So it provides the source and target information for the cables. Providing the reports in smart PDF file format is definitely one of the great benefits of Open Utilities Substation. So it's actually a smart PDF file that users can navigate from the tree on the left side. So it not only navigates to a specific component in the project by selecting a component from the left side, but users can also search for a specific attributes in the file. So if we're looking for a specific terminal in this example, simply by typing in the term, it will identify all instances in the project and will allow us to go through these instances, and will open each page based on the search criteria. Substation design is typically organized around work orders. In a CAD-centric substation design, it is very difficult to create schedules for each individual work order. In Open Utility Substation, we have the functionality to first import work orders from the SAP or other resource planning, the third-party application, and then we can assign work order to a specific components and use a thematic manager to visually see and classify changes in each work order, and of course to merge changes from the various work orders to asset files. So users can import work orders from the SAP simply by using the search criteria if they know either part of a work order name or the name of the number, the work order number, and select the work orders that they would like to import in the project, and import process starts. So there's no out-of-the-box SAP integration. There's a configuration that has to take place in the background so we can establish proper connections between SAP and Open Utility Substation. So once the work orders are imported into Open Utility Substation or they're manually created by users, the assignment process can start. So in this example, I already have assigned the life cycle status and the work order to this particular symbol, and we can of course change from one life cycle status to another. And in this project, I have two options for work order, so I can choose which work order belongs to should be associated with each symbol. When the new symbol is placed, the attributes would be the work order attributes would be assigned to that symbol. Since we have two different work orders available for the project, we would have to select which work order should be associated with this particular symbol. But if there was a single work order in the project, that work order will be automatically assigned to every new component that is being placed in the project. So in this example, I am selecting the work order number and setting life cycle status into a proposed install. Now, when we review the text attributes for the symbol, it shows those two attributes, life cycle status and work order, as a part of the symbol. And the revision number, of course, can be tracked as well, and users can change it as needed. So with a properties control, we can also assign those attributes to symbols that are already placed in the project. So let's see, maybe I didn't start using work order manager from the very beginning, and now I can go back and assign already placed component to a specific work order and life cycle status. So now after assigning those attributes to symbols, they're available as a symbol text. And we can use a thematic manager to get a visual feedback of, first of all, different work orders, life cycle statuses, and so we can combine various attributes to create themes for thematic managers. So I have only 3 themes to distinguish between components that are for removal, for installing components that are in service, and we can apply that and remove to our project. I'm going to add one more simply to distinguish between 2 different work orders, since I have 2 work orders, and distinguish between 2 work orders for different disconnect switches. So now I'm adding a third condition. So again, users can mix and match different attributes for visualizing them in thematic manner. In 2D CAD-centric workflow for substation design, frequent site visits are unfortunate reality. Those site visits are very expensive, but they're necessary for engineers and designers to understand the current conditions in their substations. With Open Utility Substation in the 3D modeling environment, we can combine the hybrid models, the reality models, and continue modeling using all the standard Open Utility Substation tools in this hybrid environment. Google Earth can be used with Open Utility Substation to communicate the exact location of your substation. So in this example, I have a hybrid model of substation. So this is a remodeling substation project where most of the substation will remain as it is. So we don't need to change the reality model itself, but we need to add some additional components using Open Utility Substation. So there are no cables in this example, so we're going to add the cables. And of course, this is the same standard navigation functionality that is available in a standard substation environment. So all the standard substation functionality is still in place in this hybrid environment. So to finish the cable placement in this model, I'm simply going to select the required cable size, select the cable placement method, and simply by selecting the connectors, the points on the connectors, and selecting the sag for the cable, see that cable is placed in almost no time. The same thing on another side. Again, I don't even have to zoom in closely on the connectors. Selecting any point in connector is sufficient because the hook points will take over and ensure that cables are properly placed between those two connectors. So in the next example, I'm looking for a capacitor bank, and simply by typing the search criteria, I'll find the correct components, and I already have the foundation for the capacitor bank in my model, so the capacitor banks will snap right in using the hook points technology on their foundation. So you can see that with minimal effort, we have a very detailed model of substation that includes all the existing conditions and additions to substation. So the most important aspect is that we can take measurements from this 3D model and make sure that all the clearance spaces are satisfied, and of course that there will be no problems with the construction later where there is not sufficient space to install specific components. So we can again take measurements through this hybrid model, or we can do a clearance detection from this model, and so on. Open Utility Substation has a built-in clash detection module. It's a power platform clash detection module. And by placing each phase at a different level, which we can run a clearance detection between different phases. So in this example, I'm running check between phases 1 and 2, phases 2 and 3. Using the same approach, similar rules can be set up for clearance detection between various electrical components and the clearance detection between the reality model and the electrical components. Users are responsible for setting up the values for clearance spaces. So in this example, I'm just checking the soft clearance space of 4 meters between phase conductors. And as you can see, there are various clashes that clash module has detected. And by selecting each one of them, it navigates right away to the place in the model where this clearance can be evaluated. Once the clearance check is complete, the results can be saved and exported for further review and analysis by the team. Open Utility Substation is the first and only integrated application for primary and secondary design of substations. Key benefits of Open Utility Substation are automatic change management, when changes to a single component instance are propagated to all instances of that component through entire project. This maintains the data integrity and eliminates manual updates. Ease of 3D symbol placement and availability of industry standard catalogs allows very quick startup times for your project. Variety of protection and control automation tools, design check tools, and reporting tools ensure consistent quality and adheres to design standards. So if you're not using Open Utilities Substation, please let's connect so we can show you how to improve your substation design and lead you to the new digital twin era of substation design. If you're already using Open Utilities Substation, let's talk about how to improve your experience and make a better product together. Thank you for your time today, and I'm looking forward to the opportunity for us to take a digital twin journey together.